Hello, everybody. I'm here for IBM, and I will talk about SAP HANA on Power Systems, new innovations to blow you away. My name is Carsten Dieterle. I'm a SAP solution architect from IBM Germany, and I want to talk about a very special project. Here's the agenda. I want to shorten, over the history from IBM Power and SAP HANA. Why you should select IBM Power for SAP HANA. Then you see the official of the complete presentation. Why and how SAP selected IBM Power for their SAP HANA Enterprise Cloud. Then I will talk to you about one really important technical improvement with virtual persistent memory on IBM Power, and we'll finish with the roadmap. History of SAP HANA on Power is since mid of 2015 when we started coming into the market 6 years after it was officially announced from SAP, but you see it here. We grow up very, very fast. We have more than 2,500 clients now. I think we are near 3,000 now. We get a Pinnacle Award 2018 for the SAP Global Infrastructure Player of the Year. That is very, very big honor from SAP for our platform, for our really solution which we provide for SAP HANA. We see that many clients as well, managed service provider, cloud service provider using IBM Power with their benefits. What makes IBM Power now really special and the best platform for your mission critical SAP deployments? I have summarized this here with really 4 points, which are really the big points that makes it really the best platform for SAP HANA deployments. First, flexibility. We have a superior virtualization and we have a scalability. We can grow from small to fast to big LPAR. We can scale in the meantime to 24 terabyte for OLAP and for OLTP workload. And that under all that is the virtualization. That means we install our HANA LPARs, which we can host on one server. A lot of these 16s are really allowed production LPARs on one server. Next point is resiliency. We have all the RAS features for really high available disaster recovery solution on our platform, and Power always has the best availability points from IDC or from different others who really measure the uptime from the applications. Performance is as well important in the HANA space. We have the highest throughput per core and the core to memory bandwidth, which is really important to transfer the data between the different layers of the cache and memory technologies. And as well, when you take all in account with the flexibility, the performance, the RAS features, and what you really can provide less, you can provide less currency, you can provide less space, less SAN and LAN ports when you set up with our virtualization in our platform. When you take really the complete TCO and altogether we are really good, and we have a better TCO than the other platform than x86. So now I want to go really in the SAP Hack project, and you see here a quote from Christoph Herrmann, Senior Vice President and Head of SAP HANA Enterprise Cloud, and you see that all the points which I have mentioned before, scalability, availability, mission critical SAP applications, and lowering TCO, that is what he sees as customer from us, and that were the points which I said to you at the beginning, which are really our proof points for our solution. And we have made a press release together with SAP. That was a joint press release, and you can leave it here. I have the links there, but that was a really great quote from Christoph. So now I want to go in the project. Here are some facts. We started a joint meeting in 2018. That means, nearly 2 years ago. The solution really cares two sites in Europe and in the US, full automated from an infrastructure point of view and application point of view. That means we coded the complete automation engine that fits in SAP's requirements, infrastructure as a code, as a word. We as well as IBM managed the platform and have really high SLAs to really provide the SLAs which SAP requests and which they guarantee to their clients. We did a small POC then at the end of 2018 and more technical details in 2019. We get a final contract in March 2019 and we kicked off the project last year in May and begin the implementation in June to September, and we were finally live in November 2019. And since March this year, we work in the second iteration of the architecture, how we provide it in HEC. But in this presentation, I will really care about the first iteration. So SAP has show us what do you have for different options. You know, IBM has always a lot of different options to make the solutions happen. We are open. We can integrate, as you see it on the left, power servers with NetApp storage. We can integrate it as direct attached with IBM storage system V9000. We can really integrate as well our Spectrum virtualize engine, which virtualize as well the storage. And in the back end, we have our flash systems, or even we have a storage attached solution with IBM Elastic Storage Server. Is a GPFS-based solution. So we offered all to SAP, and we knew that SAP has in their x86 SAP HANA Enterprise Cloud, they have NetApp storage in the backend and 6,000 servers which are doing the compute workload. So we know we should as well open or offer a solution where SAP can leverage their storage technology and keep that in the data center and just change the compute environment. So which architecture was finally selected by SAP? No GPFS solution, not the SAN solution, no direct fiber channel attached solution. They said, okay, we want the solution based on our existing storage landscape, and we change only the compute environment with power. So we offered them power servers with 190 cores and 32 terabyte of RAM, really our high-end machines. And you see here the pros and the cons of the architecture. And as I said before, with NetApp, we could leverage their existing storage infrastructure. We had no additional SAN, which provides, at least when you don't have it right now in your data center, it provides additional complexity. When you look at the project milestones, which I talked before, you see we had the fastest time to value to bring that solution up and running. And we had at the beginning a technical feature which was not officially available at this time, but we had already a technical preview version available, and we knew that it will come up very soon. And this was a network technology feature, and with that we could as well solve the problem for migrating applications during they are running when they are live, with live partition mobility from one physical server to the other. So that was the solution. I do not want to talk about the pros and cons from the other solutions. We have mentioned them here, but they selected NetApp. So how did the pod design looks like? In the primary data center, we had three E980s Power 9, and in the DR data centers, two of these machines, they had shared storage architecture. They need, when they have more servers in the primary, they need as well more storage. That's only the sizing guidelines followed, and they have a very deep technical design network architecture with different network switches, and I will show that later, but that was the setup. Here you see how we equip the equipment for the primary side with our HMCs, with our private network switches for connecting our hardware management consoles to the power servers, to connect to the switches where SAP provides the front ends or the gateways to their clients. That was the pod design for the primary. The DR side looks nearly the same, only 2 machines are there. And here you see an overview how we set it up, how was our architecture designed. We get an announcement in October 2018 that we can connect with our virtual I/O server, which is an LPAR which connects really the SAN and the LAN connectivity as one single LPAR or as a redundant dual VIO setup, as you see it here, which attaches all the network and SAN connectivity. So all other LPARs have no direct adapters assigned, so they are only assigned in the VIO servers. For booting as well, the Linux LPAR here on the left side, they want to boot as well from the NetApp storage, and we could do that with the VIO 3.1 announcement over iSCSI. You see it here, we attached that system disk, the root VG, over two VIOs directly from the NetApp over a redundant storage network, over a redundant VIO setup, and so with the multipathing driver on the LPAR in the Linux/LPAR, we see a system root VG where we install the SUSE Linux image. On the other side, you see here as well the mandatory SAP HANA file system where HANA log, HANA data, HANA shared resides in. They are, as they are doing on the x86 platform, mounted to the Linux LPAR via NFS mount. That was the overview of the architecture, and now I want to go a little bit deeper in the details. We followed the best practice iSCSI storage workflow, which was provided by NetApp, and adapted, here you see it with the blue points, we adapted these steps for the Power Platform, where we need information from SAP, from the NetApp, about the iSCSI initial name of the VIOS. We provided that, but we needed as well the iSCSI target name of the NetApp system. So that was what we adapted with the best practice of NetApp to the Power Platform. Not very specific, not very complicated, but we have to do it, and we did it completely automated, how you will see it later. iSCSI configuration, you see it here, what we have to do on each VIO server to make the disks, which were provided from the NetApp, from SAP itself, with the target name of the disk loon, what you have to do to make these disks available in the VIOS. You see here the commands, nothing special. So we have different, and you see it here with blue and green, different network subnets where we could access the NetApp storage machines, as well redundant as the complete architecture. So every component could fail. It could fail in VIOS. It could fail a subnet for the storage connectivity. It could fail a port or an adapter on the NetApp box. Everything is completely redundant, designed in the architecture. When you have the iSCSI disks here, you need as well to think about the iSCSI network, how to set it up over the different network adapter. I will show you that later, and the different target IP addresses which are mentioned in the different storage boxes. So we set it up, as I said, in 2 different subnets to have on every VO server one feed in every subnet, so that even a subnet could fail or even the complete wires could fail, and you still get the disks and the LPARs running. When you have attached and made the disk available to the wire server, you have to provide that to the LPARs. This is done via Virtualization then in the wire server. That means we have vSCSI host on our wire servers and provided these disks via vSCSI to the client LPAR. That means on our wire servers is a vSCSI server adapter running, and the clients have a vSCSI client adapter, and that is, I will say, normal behavior from wires management. Nothing special. You see as well here the commands which you have to provide on every VIOS servers to make the LUN visible in the VIOS and attach these to the client LPARs. One special point was the adapter assignment in every machine. So we did a design that every adapter, and you see it here, we used 25 gigabit Ethernet adapter with 2 ports. We assigned every adapter in every machine at the same place. That means we had a really high standardized setup, and that was us helping to provide the complete automation. We had as well the naming convention that the port 1 goes always to the top of the rack switch 1, and port 2 goes to the top of the rack switch 2. That were just rules which we defined. The biggest part in the project was the network connectivity, how to do that. We have different subnets and different VLANs. Everybody knows that who is working in the HANA space. We have storage attachment where we have the data on the persistent data on the storage side. We have to access that when we start HANA, or even when we do the delta merge and do save points to the disk. There you need a storage network. We have a network then where we use for live partition mobility, because when you want to transfer one LPAR to the other, you want to have a really high bandwidth network which provides you the maximal performance that you can do the switch in the shortest possible time. And as well, you need the connectivity to the SAP app service, to the HANA clients. That means to the client outside of the cloud at their locations. That are the different types of network VLANs which you have to take care of. Then we have as well a private network between HMCs and the power servers. We have an admin network, and that were really the task which we have to take care of, and that was the biggest part of. Here you see how we did it with the different MTU sizes, because for admin network we need only a MTU size of 1500. For the big part where we have a lot of storage or data transferred from the storage VLAN, we have a MTU size about of 9000, and you see it here. We have completely done a redundant setup as well here, that every port of the adapter goes to a different BIOS and vice versa, so to different top of the rack switches, so that as well here a top of a rack switch can fail, a complete adapter can fail, a BIOS can fail, the architecture will continue working and running. What we used a special feature from the adapters which we provided. I said we were using the 25 gigabit adapters, and we used SR-IOV cable adapters. That means we can really virtualize on the adapter level. And you see it here, we used it in the multi-partitions through wires deployment model. That means we have multiple HANA partitions on every server, but we go through the BIOS, and we could really provide the virtualization on the adapter level through the BIOS through this technology. On top of this SR-IOV technology, we used virtual NIC technology, VNIC technology, to really solve the LPM issue. Because when you use live partition mobility, LPM, you have no dedicated adapters. You need only virtual resources. That means virtual fiber channel adapters or virtual network adapter. As I said here, we used only virtual network adapter. And the big benefit of this is that we can, with that technology now as well, resolve the LPM issue. It's described here how the setup was designed, and the virtual functions of such an adapter, and we had here the 25 gigabit adapter, where we can use 40 virtual function. These virtual functions were directly connected to the BIOS, and in the BIOS, these virtual functions were really connected to a VNIC server, and this VNIC server was connected to the VNIC client on the client partition. That means the complete traffic from the data point of view was really done from the client directly to the adapter. You see it here on the screen. And only the administrative, the metadata flow from the VNIC client to the VNIC server. And that makes a big performance impact improvement to the previous virtualization features on the Power Platform with probably SIA. With that technology, we were able to set up here a LHCP configuration, because SAP said to us, in the client LPAR, we need 100 gigabit bandwidth. And you see it here. We have done it with 4 ports together and bonded these 4 interfaces to one channel, which means 4.4 times 25 gigabit means we had then 100 gigabit bandwidth. And we did that over 2 different wires, as mentioned in the middle, over the different 25 gigabit adapters connected to the, and completely redundant connected to the top of the rack switches. You see here, when we add one more LPAR, the picture comes a little bit more complex, but as I said before, all this was directly and fully coded by us in the setup. Here you see the a BIOS view of the SR-IOV adapters, because as you saw before in the picture from the Power 9 servers, we had 8 25 gigabit adapters, which were really assigned to the client LPARs, and we had 1 additional adapter for the iSCSI attachment and as well for live partition mobility. Why we did that? Because we said, okay, the iSCSI performance where we boot our root VGs will not have that much traffic. And when we have to move a LPAR, we can really use that complete adapter for live partition mobility to get the full performance. So that was the reason behind that. When you then look at one LPAR, at a complete summary, what we did the iSCSI attachment of the root VG disk. I explained that before, and as well, I said to you or explained to you how we did the bonding to provide the 100 gigabit bandwidth in the client adapter over the VNIC SR-IOV technology over the selected 25 gig adapters and then the ports. So that was the LPAR summary, which we have to provide as well in the BIOS and as well as code for installing this kind of architecture. The end-to-end provisioning, which you see here, is that really when a client contracts a contract to host a HANA LPAR or a HANA instance in SAP HANA Enterprise Cloud, that, yeah, I will say the IT department is not really included, that the seller, when he gets the contract, can really provision and deploy such an LPAR for the client, because we just changed, and you see it here in the middle, our IBM Power Server and our HMC with the already existing end-to-end provisioning from SAP. You see it here, Llama landscape menu, SAP landscape management is as well integrated, and so we did, and here is the process which SAP defined, and that is a SAP foil, what we have to do, the different steps when they request a new LPAR, what has to done in the automation engine. And so we integrated our power servers, our HMC with the code to provide the wire servers automatically, to do the completely network provisioning, the different setup of the VLANs, all that stuff, and finally to install the LPAR, to install a HANA instance, to make the network connectivity to the client side as well available. Key takeaways from that: we see a lot of MSP CSPs are now selecting IBM Power Systems for the deployment, and SAP is a really big project and a big, I will say, a big example for others how they can do it. iSCSI support is now available with Virus Read that helped us to connect network attached storage. VNIC SR-IOV technology, I talked about it, enables us to provide high bandwidth on the one side, low latency on the other side, and really high secure and as well LPM technology enabled solution. And a next big advantage was capacity on demand. So SAP only had a part of the resources available, and when they host or get new clients, they can really enable the new resources which they need for the installation on the fly. The complete setup we did together with our partner NetApp. We did a best practices setup, and that is available here on the following link, and as well in IBM Tech Docs. Before I end, I want to just give you a new feature available as well on SUSE Linux with virtual persistent memory for SAP HANA on IBM Power System. It's a complementary offering from IBM to Intel Optane, where they as well use persistent memory, and we as well have now made this solution available. We can do that very granularly on every LPAR. That means we have the same DRAM as we have for the working and row store and the delta merge area. We use the same memory DIMMs as well for the main region, which is the main part for use case for the persistent memory. So that means no hardware change, same memory modules, and for the persistent area we create a volume, and on this volume we create a file system which is mounted as with the DAX option, and the persistent memory helps you when you have to reboot a HANA instance, you have to upgrade an HANA instance, or even when you have to upgrade SUSE Linux from one service pack to the other. And you see here as well the requirements for bringing up that solution. You need Power 9 servers, new firmware, HMC version from /15 SP1, it's available now, and as well you have special requirements regarding the HANA release. You can do that, as I said, configure on the HMC, on the hardware management console, no additional cost. It's as well full virtualized over Power VM, and it's available nearly since 5-6 months. I will end with the roadmap for 2020. You see the blue stuff here, which we already had in the last time and in last year. But for 2020, we have a roadmap to provide more than 24 terabytes, which is our scalability at the moment. We have clients who want to grow more to 32 terabyte. We will have additional support for SUSE and as well for Red Hat releases. SUSE SP/12 SP5 and /15 SP2 will be certified. We will have a new hybrid memory solution as well, testing, where we provide more capacity with lower latency modules as well for the memory to really take care for big HANA LPARs. So there is a lot of development and ongoing in this space, and yeah, we have a good roadmap. All is available, and Power is the choice of your choice when you want to have really high available, high performance HANA deployments in your data center. With that, it's time for questions, and I will close the session now. Thank you for attending. Have a good day. Goodbye.